Hello everyone, welcome back to my YouTube channel Learning Catalyst. In today's video, we will be learning about carbon, its occurrence, properties and allotropes of carbon in the chapter Carbon, an Important Element. So let us first look at what is a carbon. The element carbon is available abundantly in nature and occurs in free as well as combined state. The free state is classified as crystalline and amorphous, whereas combined state is classified as inorganic and organic compounds. Some examples of free state are diamond, graphite, and coal, whereas in the combined state, carbon can occur as carbon dioxide, polymers, or as functional groups such as carboxylic acids, esters, etc. The element carbon is usually denoted by a symbol that is a capital C. It has an atomic number of 6, atomic mass of 12 and electronic configuration of 2, 4. It has a valency of 4 electrons and it's a non-metallic element. Now let us look at how carbon occurs in nature. The word carbon comes from the Latin word carbo, which means coal. In the Earth's crust, carbon is present to the extent of approximately 0.27% in the form of carbonate, coal, and petroleum. Let us now look at the properties of carbon. The most significant property of carbon is the allotropic nature. Some elements occur in nature in more than one form. The chemical properties of these different forms are the same, but their physical properties are different. This property of elements is called allotropy. Like carbon, sulfur and phosphorus also exhibit this kind of property, that is allotropy. The first allotrope of carbon is the crystalline form. A crystalline form has a regular and definite arrangement of atoms. They have high melting and boiling points. Carbon has 3 crystalline allotropes. The first crystalline form of carbon is diamond, second is graphite and third is fullerene. Now let us look in detail for each. First is diamond. Diamonds are found in India mainly in Karnataka and Madhya Pradesh. Diamonds are also found worldwide in South Africa, Brazil, Belgium, Russia and America. Let us now look at the structure of diamond. In diamond, every carbon atom is bonded to 4 neighboring atoms by covalent bonds. Due to this, 3-dimensional structure is formed, which makes diamond very hard. Let's now look at the properties of diamond. Brilliant and pure diamond is the hardest natural substance. The density of diamond is 3.5 grams per centimeter cube. The melting point of diamond is 3500 degrees. When diamond is heated at 800 degrees Celsius in the presence of oxygen, carbon dioxide is given off. Diamond does not dissolve in any solvent. Diamond is also a bad conductor of electricity as it does not have free electrons. Diamonds are used for various purposes, such as for glass cutting, in ornaments. Diamonds are also used as knives for eye surgery. Diamond dust is used for polishing other diamonds, etc. The next crystalline form of carbon is graphite. Graphite is found in the natural state in Russia, New Zealand, America and India. Let us now look at the structure of graphite. Every carbon atom in graphite is bonded to 3 other carbon atoms in such a way that a hexagonal layered structure is formed. A graphite crystal is made up of many sheets or layers of carbon atoms. These layers slip over each other on applying pressure. One layer of graphite is called graphene. Properties of graphite are: graphite found in nature is black, soft, brittle and slippery. Inside each layer of graphite, free electrons move continuously within the entire layer. That is why graphite is a good conductor of electricity. Due to the layered structure, graphite can be used for writing on paper. The density of graphite is 1.9 to 2.3 grams per centimeter cube. Graphite does not dissolve in most solvents. Let us now look at the uses of graphite. Graphite is used for making lubricants. It is also used for making carbon electrodes, Graphite is used in pencils for writing. Graphite is used in paints and polishes. Graphite is also used in arc lamp, which provides a very bright light. The next allotrope of carbon is fullerene. Fullerene is rarely found in nature. It is found in soot and in interstellar space. The first example of fullerene is Buckminster fullerene, that is carbon 60. Let us now look at the properties of fullerene. Molecules of fullerene are found in the form of buckyballs and buckytubes. Fullerenes are soluble in organic solvents such as carbon disulfide and chlorobenzene. Fullerenes are used as insulators. They are also used as a catalyst in water purification. At a certain temperature, fullerene exhibits superconductivity. Now that we have learned in detail about the crystalline forms of carbon, let us now look at the non-crystalline form of carbon, or the amorphous forms. The arrangement of carbon atoms in this form is not regular. Coal, coke, etc. are the non-crystalline forms of carbon. Coals are of different types. First is peat. Formation of peat is the first step in the formation of coal. It consists of a high proportion of water and less than 60% of carbon. Therefore, not much heat can be obtained from peat. Second is lignite. Peat was transformed into lignite due to increased pressure and temperature inside the earth. It contains 60 to 70% of carbon. Lignite is the second step of the formation of coal. Next is the bituminous coal. Bituminous coal was formed as the third step of formation of coal. It contains 70 to 90% of carbon. The last one is anthracite. Anthracite is known as the pure form of coal. This coal is hard and contains about 95% of carbon. Next one is charcoal. The charcoal that is made from animals is made from their bones, horns, etc. On the other hand, the charcoal made from plants is formed by combustion of wood in an insufficient supply of air. Next is coke. The pure coal that remains when coal gas has been taken away from coal is called coke. Coke is used as domestic fuel. It is also used as a reducing agent. It is also used for the production of aeriform fuels such as water gas and producer gases. Let us now look at hydrocarbons. Along with carbon, the element hydrogen is also included in most organic compounds. The compounds formed from only carbon and hydrogen are called basic organic compounds. Hydrocarbons can be saturated and unsaturated. A carbon atom exhibits a characteristic property. When a hydrocarbon forms a single bond, it is called saturated hydrocarbons. But if they are forming multiple bonds such as double bonds or triple bonds, it is known as unsaturated hydrocarbons. They are ethene, propene, propyne, etc. Next is carbon dioxide. Carbon dioxide occurs in the air in the free state to the extent of about 0.03%. Exhaled air contains about 4% of carbon dioxide. To test this, you can take a freshly prepared lime water in a test tube, blow for some time into the lime water through the straw and observe the lime water. If carbon dioxide is present, it will turn the lime water milky or whitish in color. Uses of carbon dioxide. Carbon dioxide is used to make aerated drinks. Solid carbon dioxide is also used in cold storage. They are also known as dry ice. Carbon dioxide obtained by chemical reaction or kept under pressure is used in fire extinguishers. Liquid carbon dioxide is used to remove caffeine from coffee. Liquid carbon dioxide is used as solvent in modern eco-friendly dry cleaning. Lastly, plants use carbon dioxide in air for photosynthesis. So in today's video, we have learned about what is a carbon, its occurrence, properties and allotropes of carbon. The allotropes of carbon are crystalline or non-crystalline or amorphous. The crystalline form of carbon are diamond, graphite and fullerene. The non-crystalline form of carbon is coal, charcoal and coke. Next is hydrocarbons. Hydrocarbons with single bond are saturated hydrocarbons, whereas hydrocarbons with double or triple bonds are called unsaturated hydrocarbons. We had also learnt about carbon dioxide, and the presence of carbon dioxide can be observed in the lime water experiment. That's it for today's video. Thank you for watching. Don't forget to like, comment, share and subscribe to my YouTube channel. Thank you.